Hello and welcome to MVP Days. Today's session is about how you can manage your Kubernetes clusters with Microsoft Azure Arc. My name is Janaka Rangama and I'm a Microsoft Azure MVP and a Microsoft Certified Trainer. I'm a Senior Principal Engineering Technologist for Microsoft Hybrid Cloud at Dell Technologies. Without further ado, let's see how we can leverage Microsoft Azure Arc to leverage managing Kubernetes clusters in any environment. First things first, what is Azure Arc? Azure Arc is a management framework that will allow simplifying governance and management of your cloud resources by delivering a consistent multi-cloud and on-premises management platform. Azure Arc enables you to manage your entire environment, and it provides a single pane of glass by projecting your existing resources into Azure Resource Manager. Now with that, you can manage your virtual machines, Kubernetes clusters, and databases as if they were running on Azure itself. So these resources can be on-prem or in Azure Stack or in Google Cloud or in AWS, but will be still first-party resources in Azure. So regardless of where they live, you can use familiar Azure services and management capabilities with Azure Arc. And it allows you to continue using traditional IT ops while introducing new DevOps practices to support new cloud native patterns in your environment. Now, the full ecosystem of Azure Arc comprises of several components. Now, Azure Arc supports running the components in any infrastructure. So you can have any server, any SQL server, or any Kubernetes cluster running on Azure Stack HCI, or on Azure VM, or on Azure Stack Hub, or any AWS GCP infrastructure onboarded to Azure Arc. Now with Azure Arc, you can leverage the same services that you're used to, like Azure Policies, Azure Monitor, Azure Security Center, and Azure Resource Groups, Azure Log Analytics, those same Azure governance constructs to manage your cloud resources. So if somebody asks, can I use the same with VMware or physical servers? Absolutely. Azure Arc for servers enables you to manage just that. Now, there are a couple of components in Azure Arc. Azure Arc for servers, Azure Arc for Kubernetes, and Azure Arc for data services. Now, in today's session, we are going to discuss about the Azure Arc enabled Kubernetes public preview. Now, with Azure Arc enabled Kubernetes, what you are getting is a single pane of glass operating model for anyone to for their Kubernetes clusters deployed across multiple locations. Now, this brings the Azure management to the clusters themselves so that you can leverage the Azure capabilities such as Azure Policy, Azure Monitor, Azure Resource Graph inside those Kubernetes clusters. Now, by bringing every system into Azure Arc, it is much easier to establish clearer roles and responsibilities for team members based on a clear separation of concerns without sacrificing the visibility and access. Now, you can attach and configure Kubernetes clusters inside or outside of Azure by using the Azure Arc enabled Kubernetes preview. So when a Kubernetes cluster is attached to Azure Arc, it will appear in the Azure portal. It will have an Azure Resource Manager ID and a managed identity. Clusters are attached to standard Azure subscriptions and are located in a resource group as it would have been deployed in Azure. And they can even receive tags like any other normal Azure resources. So if you look at the architecture for this solution, your Kubernetes clusters can live in any environment. So for an example, you can still leverage this inside AKS itself, or it can be a Kubernetes cluster deployed in a VMware server, a couple of VMware servers, doesn't matter. Azure Arc will onboard the cluster as its own and will provide you the same management capabilities. Now, without further ado, let's see a demonstration on how we can onboard a Google Kubernetes Engine or GKE cluster with Azure Arc, and how we can leverage Azure Monitor to monitor that GKE cluster from Azure itself. Now over to the demo. Now first, we are creating a service principal for this Azure Arc Kubernetes cluster that we are going to deploy. So we can do it in multiple ways, but I've chose to use Azure Cloud Shell. And the first part is to actually create the service principal. Now, as you can see, the service principal has been created. And once that is done, next thing is to register the Kubernetes providers. So you will notice that first time you do this, it'll take some time, like a minute or two, for the Kubernetes resource providers to be registered. But in my case, which it has been already done, and when I run the commands to check the status, as you can see now on the screen, it'll say the resource providers are already registered. So the first one is completed, and I'm gonna switch over to the next one, and yes, that's also registered in that case. So bear in mind, the first time you do it, it'll take some time for it to be completed, the registered status. Now I'm switching to my GCP console. So I'm creating a new project. Here I'm giving it a name called the Azure Arc GKE demo. And once that is done, there are a few things I need to grab from the project settings. So I need to get the project ID. And yes, you can see the project ID there. And once the project is completed, I have to enable a few of the APIs in order for me to deploy resources through a Terraform project. So if I go to the project now, I can see the project ID there. This is required at a later stage. So first thing I'm going to do is I'm going to enable the Compute Engine API. So I'm just searching for the Compute Engine API on the GKE console. And next thing is I'm going to enable the API. So it's just a one click of a button. It'll take some time to enable that. And once that is done, I need to create a service account. So go to create credentials, service account, and give it a name. So I'm gonna create a service account for this Kubernetes cluster that is I'm going to deploy in the Google GCP environment. So I'm naming it as Arc Demo, giving it a description now. And once that is done, I have to give it the required permissions for this project. So I'm just double checking the information, Arc Demo. So I'm just adding AZ into the front. So click create. And then I have to give the correct permission. So here I'm giving an owner permission for this project. And if I want, I can give other users access to this service account as well, who has access to the same GCP subscription. All right, so now that's done. The next thing I have to do is, once the credentials are generated, I can go and add a private key, which I'm going to use at a later stage to authenticate. So I'm going to add a key here, and I'm going to create a new key on JSON format, and I'm going to create the key. It's asking me to save. So I'm going to save it to my demos location, and voila, so it's saved. Now the key has been saved, and if I just browse the key and to see what's inside, it will contain the authorization information about the GKE environment. Sorry, the compute app engine. Now the next thing I'm going to do is I'm going to copy over that key to my Linux virtual machine. So actually I'm running WSL on Windows. And here we have the Terraform folder where I have created the Terraform config as well. So once that is done, the next step would be to enable the Kubernetes API. So I'm gonna enable the Kubernetes Engine API the same way I did. I'm gonna search for that, and once it's found, I'm gonna just click enable. So I just don't have to create any other service accounts. That's the only one I have to create. So once it is created, we are ready to go ahead with the deployment of the Kubernetes cluster via Terraform. So I'm not gonna explain much detail about what Terraform is and how it works. At this stage, what I have done is I've installed Terraform on a virtual machine, in my case the WSL environment, and I have cloned the repository. In that repository, the code is able to deploy a GKE cluster to the GCP console. So what I'm going to do is I'm going to provide the parameters, the environment variables required for Terraform to identify my GKE cluster. So you can see that I have given the GCP credential file names with that JSON file I've just saved. Now, if I look at the Terraform files, you can see how the actual deployment happens and what are the components of the the resource definition. And if I go to the providers.tf, you can see what are the providers that I'm going to use there. And no, that's not it. So I'll quit from here. No, it should be simple. Yep. And if I go to the variables.tf, it'll that's the place where I define those environment variables. So the environment variables have been set. So I don't really have to provide an input when I run the script to deploy this Terraform environment. So with Terraform init, I'm initializing the environment, and then I'm going to apply with an auto approve parameters. So it will automatically start the creation of the cluster by getting the same parameters that I've defined in the environment variables into the variables.tf. Now this can take some time depending on the time that GKE takes to create an environment. So as you can see, the cluster is being created. So for my demo, for this particular demo, it took me roughly around like 5 to 8 minutes for the cluster to be completed. So as you can see that it's completed now. And that's pretty much it. So I've created a cluster with Terraform. Now what I have to do is I need to make sure that I have onboarded this to my Azure environment. So now as you can see, this script I'm going to use has some parameters that contains data about the Azure environment. So it contains the subscription ID, and some of the other parameters that are there are the app ID and the tenant ID that I generated with the service principal in the first action I did. So I'm now connected to the Kubernetes cluster there, and I have uploaded that shell script and I have executed that. So with this, what it does is it's installing Helm, and it's installing the Azure CLI and other required components that are needed to onboard this cluster to Azure Arc. So one thing you have to keep in mind is if for some reason any parameter in that shell script is wrong, you might face an issue with a broken Helm installation. So if you try to continue that, it'll complain about Helm being installed in the backend or something like that similar. So you need to make sure that you get all the parameters in the right in the first place, or you have to destroy the cluster and start over again. Now as you can see, if I move to the Azure portal, you can see under the Kubernetes clusters preview, I already have a GKE cluster set up. So my first step of my demo is completed, onboarding the GKE cluster into Azure. Now, the second thing I want to do is I want to get the same Azure Monitor capabilities. As you can see, the Azure Monitor is not enabled here for the GKE cluster. So to do that, what I'm going to do is I'm going to onboard my GKE cluster to Azure Monitor so that I can leverage that to monitor the GKE environment. So as you can see, I have another script that I'm using for onboarding the GKE cluster for Azure Monitor. So I'm gonna upload the same script to my GKE shell and gonna execute from there. So all this cluster does, this one does is it'll create a new OMS workspace, Logantics workspace, and the same parameters that we provided earlier, tenant ID, app ID, resource group, things like that we have to provide so it can successfully connect to the desired Azure Arc cluster. So now the sequence has started. So as you can see, it's deploying the components that are required for this to be onboarded to Azure Monitor. It'll take some time, probably 5 to 10 minutes to complete, depending on the connection you have. And once that is done, you can see through Azure Monitor that your Azure Arc cluster can be monitored to your Azure Monitor environment. So it will take some time, like 5-6 minutes to refresh and get the data here. So I'm going to go back and see after some time whether the information is there. All right. So as you can see, the information is being pulled now. So you can see all the nodes that are in my cluster. And if I expand them, you can see the runtime and various other Azure Monitor for Containers configurations out there. And if I switch over to controllers, you can see what are the controls there. And finally, you can see the containers. If I move to containers, you can see what are the containers that are currently running on my GKE cluster. But all these informations I'm getting through the Azure Arc onboarded cluster. So I don't have to, if I have like 10 different cloud environments with 10 different Kubernetes clusters, I can still use Azure Arc as the management engine to manage them all. Well, I hope this session has been valuable and you have learned a thing or two about managing Kubernetes with Azure Arc. Thank you for joining this session again and hope to see you on the next one. Have a good day.